Hello everyone, welcome to Data Structures course. The data structure subject is an important subject because to become a good programmer, you must understand the concepts of data structure clearly in order to write your code efficiently. In this series, I am going to present the data structure concepts as video lecture. Let's get into the topic. In this presentation, I am going to cover what is data structure, importance of data structure, types of data structure, and some real-life applications of data structure. Before getting into what is data structure, we must know what is data and information. There is a difference between data and information. Let's see what is data. So data is a collection of raw facts. It may be numbers, it may be words, characters, image or anything. For example, we have taken 40, 50, 70 and 90 as example of data. And our second example is 𝐴𝐧𝐾𝐬. It is actually meaningless. It is not conveying any information to us. Even though it is not conveying any useful message, we call this as raw data. And we'll see when this data becomes information. This information is a processed, structured and organized data, which means once your raw data is processed and it is organized, if it conveys some useful and meaningful message to you, at that time, your raw data becomes information. So, your information must convey some useful or meaningful message to you, whereas your raw data is not so. It is not necessary that your raw data must convey some useful information, but your information must convey some useful data to you. Let's see an example. Here we have labeled that 40, 50, 70 as test marks and we have processed this test marks 40, 50, 70, 90 and we got an average score. This average score is nothing but our information. Out of this raw facts, I got this useful information average. Processing is nothing but here calculating average. So when I process and organize this data, I got some useful information which is nothing but average score, that I can say information. So this is the difference between data and information. Can you guess what is it? Yes, it is a library, but the books are scattered all around. If you want to fetch a particular book from this library, is it easy? In a stipulated time, you cannot do it. For searching and fetching a book in this unorganized library is a tedious process. But whereas, when you consider the second image, here the books are well maintained. If you want to fetch a particular book, it is easier for you to search and fetch a particular book because the books are in an arranged way. It is an arranged library. So the thing is that when objects are in an arranged manner, we can easily fetch and process it. If it is not so, it's a tedious process. The same is applicable to your data. When you want to store your data in a computer memory, then you must add structure to your data and you must store your data in an organized way. Then only you can manipulate that data easily. Now we'll see definition of data structures. A data structure is a way to store and organize your data in a computer memory so that it can be used efficiently. Which means when you want to store your data and you want to process your data in a computer, then your data must be structured in order to manipulate your data efficiently. Just consider you want to store 100 students' marks, and if you want to process 100 students' marks, then you will be in need of 100 variables. But keeping track of these many variables is a tedious process. For that, we can use array data structure. This array data structure, it holds group of data elements of same data type, and it stores your data in contiguous memory location. So with the help of this index position 0, 1, 2, 3, we can easily update any data, we can remove any data element, we can insert any new data element into your array. In array, your data will be in an organized way so that you can remove, insert or update any data item easily. Next, we'll see importance of data structures. Adding structure to your data makes your algorithm much simpler and easy to maintain. Handling huge amount of data, this data structure is important. And fetching and processing your data in an efficient way, data structure is very much needed. And next is types of data structure. Data structure is broadly classified into two types. One is primitive data structure and another one is non-primitive or secondary data structures. So in non-primitive data structure, we have linear data structure and non-linear data structure. We'll see one by one. Let's begin with primary data structure. This primary data structures are defined by the programming language and not by the programmer. So this can be directly operated upon any machine level instructions. For example, in C language, we have built-in data types like integer, character, float, boolean. So these comes under your primary or primitive data structure. So primary or primitive data structure, we call it as inbuilt data types. And next is secondary data structure or non-primitive data structures. So these non-primitive data structures are derived from your primitive data structures. And it is not defined by any programming language, and it can be created by the programmer. Let's say example array data structure, it can be created according to their need. A programmer can create array data structure, linked list, stack, queue, tree and graph data structure. So this non-primitive is divided into two categories. One is linear, another one is non-linear data structure. And next we will see linear data structure. So in linear data structure, the elements are stored in linear or in sequential manner. That is one after another. For example, arrays, stacks, queues and linked list are example of linear data structure. This is our array representation. So here the elements are stored in contiguous memory location and it is stored in sequential fashion, that is one after another. So next is non-linear data structures. In non-linear data structure, the elements are not stored in linear order, but it follows parent-child relationship, which means we can say it follows hierarchical ordering. The examples are trees and graphs. We'll see some real-life applications of data structures. Probably we use the social networking applications like LinkedIn, Facebook, Instagram. So this all application uses a data structure called graph data structure, and this is the representation of graph data structure. and our Google Maps. We all use Google Maps nowadays to find any shortest path between source and destination. For this purpose also, Google Maps use graph data structure. And the next is redo and undo operations in word processor. For redo and undo operation, a data structure is used called stack data structure. Likewise, data structure is used in different purposes. A small recap of the session. What is data structure? A way of storing and organizing data into your computer memory. And types of data structure. It is broadly classified into primitive and non-primitive. And non-primitive, it is again divided into linear data structure and non-linear data structure. Importance of data structure. We need data structure to fetch and process our data in an efficient way, and to handle huge data structure is needed. And next is some real-time applications of data structure. That's all for this session. We'll meet you in another session. Thanks for listening.